In this video, we're going to talk about all kinds of authentication and authorization flows, and we're going to cover cookie authentication and authorization flow, and we're going to cover custom token authentication and authorization flow, and then we're going to move on to OAuth authorization code flow for web applications, and then OAuth authorization code flow for mobile applications. And then we're going to cover the security risk for mobile application, which is introducing Pixie, right? And then last but not least, we're going to cover the OAuth authorization code flow for desktop applications. My name is Frank Liu, and welcome to my channel. While watching this video, if you like this video, please give it a like and don't forget to subscribe to my channel so you won't miss next video like this. You can also use the table of contents in the description area to jump to a specific part of this video. So let's jump right into our authentication and authorization flow in 1 hour. All right, before we can do anything, I need to make sure that you understand one thing, which is called redirection. And the reason is that redirection is being used in all kinds of flows, whether it's for cookie authorization or token authorization or OAuth. So this is really a key thing to understand in the first place. So if you have done some web application development or you have learned about it, you might know this concept that is called redirect, right? So in ASP.NET Core or ASP.NET, you have this thing that is called response.redirect. I need to make sure that you understand how this works under the hood, right? So this one takes a parameter, and then that parameter is the URL. So imagine that you are the user and you're using the browser to go to a particular website, and this browser is going to send the URL that you typed in the browser, and then it will send a HTTP request to the web application, right? And imagine this web application, for whatever reason, it redirects you to a different web application. Let's call this web application number 1, and this web application actually redirects you to web application number 2. And now your browser is going to show the web application number 2's page instead of web application number 1's page. And although this chart or this diagram looks like this, it doesn't really work like this. The request doesn't simply jump from the browser to the web application number 1 and then directly jump to web application number 2. I need you to really understand how the redirect actually works. Okay, so I'm going to draw a diagram. So this is the user, and this is your browser, and this is web application number 1, and this is web application number 2. Right? So I'm going to draw a sequence diagram to show you exactly how the redirect works. So what happens here is that you type in the URL, right? And then that URL that is used to send a HTTP GET request from to the web application number 1. And the web application number 1 actually does not do this. It does not just redirect you like that. It doesn't work like that. How it works is that it will actually return a response. So remember this, every request from a browser will have a response, whether there is a redirect or not, right? So this actually returns a response, and this response is a HTTP 302, right? And that's, I think it's called permanently relocated, something like that. It's going to tell you that this URL that you're requesting is permanently relocated. So, and then it will come back with a location header, right? So HTTP has, any HTTP request or response has headers. So this particular response has a location header, and this location header contains a URL to web application number 2. And when the browser receives this type of response, what it does is that it's going to automatically, without the user interaction, without user's interaction. It's going to redirect you, right? It's actually send another HTTP request, and the URL of that request is just this URL, right? And then from web application number 2, it's going to send a response back and render the HTML of web application number 2, right? This page. So this is how redirect works. And OAuth 2, or actually any web applications when it comes to authentication and authorization, use this redirect concept extensively. So that's the first step. We need to understand how redirect works in web applications. Now that you understand how this works, let's take a look at how authentication and authorization works in a typical web application. All right, so you are going to have a user, right? And then you have your browser. And then you have your web application. Again, this is going to be a sequence diagram, which is going to be a great tool to help you understand how this works. Right? So you know the URL, you provide the URL, and then the browser is going to send a HTTP GET request to the web application. Now, the web application knows that this URL is a protected resource, right? Which means it cannot just provide the HTML to you without asking you to log in. Now, the web application will return a HTTP 302 response with a location header, and that location header has a login page URL. And the browser sees that the response is a HTTP 302 permanently relocated, and then it will go into the location header, takes the URL, and what it does is that it's going to redirect, right? It's going to send another HTTP GET request using this particular URL. So then the web application is going to render the login page, right? So it's going to return the HTML of the login page. So it's the login page HTML. So the user then sees the login page, right? So the user is going to input credentials, right? Credentials. And then it will click on the submit button, right? So then what happens is that the credentials is submitted, right? So username and password is submitted to the web application. Here, the web application is going to do a lot of processing, right? It's going to verify credentials, first of all. If the credential is correct, then, okay, the second step is sign in the user, right? And it creates a user principal object that represents the user that is logged in, or the logged in user. And then it's actually going to create, so this sign in process, actually first it will create a user principal object, and then it will create a cookie. It's going to create a cookie object, and then it will pack that cookie object in the response and send that cookie back to the browser, right? So that's going to be a security cookie. Of course, that cookie is encrypted, and with any subsequent request, the cookie can be used. So in this case, this can be also another HTTP 302, and the location header now is the original requested URL, right? And then the user is going to, so the browser is going to redirect you again to the original URL. Only this time, it also sends the cookie, right? It's going to also send the cookie with the URL request. And now the web application sees the cookie, right? It verifies the cookie and knows it's this user. And then it's going to do whatever it does, right? So process. So this is going to be the business logic here, right? Business logic. And then it's going to spit out the HTML that the user wants to see, basically the page that the user wants to see. So this is a typical web application, right? Where you have all of the authentication and authorization inside the web application itself, right? The web application does that by itself. So this is a typical cookie-based authorization where a cookie is being used and passed back and forth between the browser and the web application. And the cookie carries information about the user and the security context, right? It tells the server what the user, who the user is, and what the user have access to. OAuth, and on the other hand, is a specification, and it's based on token authentication, right? It's token-based authentication and authorization, right? So before we talk about OAuth, let's talk about token based authorization and authentication in general, so that you know where OAuth comes from, and it's easier for you to understand what OAuth really is, right? So token-based authentication can work like this, right? So let's move over here, and again, we're gonna have our user, we're gonna have our browser, and we are going to have our web application, right? And again, we're going to use sequence diagram to illustrate what is going to happen between the three different parties, right? Again, the user can input the URL, and the URL will be sent as HTTP GET request to the web application. The web application sees that, you know, it's a protected page, right? Then it's going to do a HTTP 302 with location header points to the login page, right? Now it accesses the login page, the login page URL, right? And then it will return the login page HTML. So then the user input the credentials and submit the credentials, right? And here's is going to be a little bit different from the cookie-based authentication, right? So here it's going to it's going to authenticate the user, right? It's going to authenticate the username and password, and then it's going to generate a token, right? That's the first step, and then it's going to generate a token. The token is just a string, right? It can be a unique identifier, which doesn't mean anything, right? It's a random string. It can have some information in it, right? So let's say if it's just a unique identifier, right? If it's just a unique identifier, or let's call it global GUI ID, right? And this unique identifier will be saved in the database, right? So in the database, there's going to be a table that stores the information about the token, right? So this is the token, and you know which user it corresponds to, and then when it's going to expire, right? It can store a lot of information, right? The expiry date here is very important, right? So it stores the token in the database, and then it's going to then sign in the user here, right? So here it's going to store token in the database, and then it's going to sign in the user. Instead of generate a cookie, it's going to just pass that token back, right? So you can pass that token back. So this is going to be token in the response. It passes the token back to the browser, and the token is in the response, right? And in the subsequent request to the web application, it always passes the token to the web application, right? The basic way to pass the token is to append the token as a query string, right? It's in the URL, which is not secure, because it's going to store in the history. But the token, remember, the token has expiry date. So it's not too bad when it's in the URL, but it's better to be in the header instead of in the URL, right? So it's just going to pass the token to the web application, and then the application processes and then return it, right? And another good thing about this token-based authentication is that now it can access some resources like an API, right? So now if one of the requests to the web application actually needs some data from the web API or some information from the web API, it's going to send a request to the web API, right? Of course, that's a HTTP request with a URL, but it's going to pass that token along with that URL. And then what this web API is going to do is it's going to verify the token against the token store, right? Against this table, right? And then, it verifies it if everything is good, right? Token hasn't expired and it's valid, it exists in the table, then it's going to return the data, right? And then the web application processes the data, and then we'll return the HTML to the browser. So that's a very basic token-based authorization that I remember more than a decade ago. We used this type of token-based authorization for what purpose? For single sign-on, right? So we have this single sign-on service here, which contains a token store, right? Database-based token store. And then we can pass that token back and forth. So you can implement this kind of like custom-based token authentication and authorization. Right? You don't have to follow OAuth, but OAuth is really popular nowadays, and most providers follows the OAuth specification, right? For example, all the social media OAuth providers like Facebook, Google, LinkedIn, Twitter, they all have their version of OAuth implementation. And if you want users to log in with their social media accounts, then you really have to follow OAuth. So let's look at OAuth. We still have a user, right? And we're gonna have a browser. And we have our web application. And with OAuth, we actually usually we need to access some resources. For now, use the web API as the resource. So the web application needs to access the web API. Web API is the resource. The web application is the client, right? And then you also need something that is called the OAuth server, right? Or the OAuth provider. So there's terminologies there, right? This web application here is the client, and this OAuth server is the OAuth provider, right? And the web API is the resource. So what we're saying here is the web application needs to access the resource, right? The client needs to access the resource through the authorization server, right? Let's see how that works. And this is the authorization code flow. Authorization code flow is the most secure flow. And after this, we're going to take a look at how the authorization code flow can be used with native apps like mobile apps. So of course, first of all, we are going to, the user is going to input the URL just like before, right? And then this URL is going to be sent to the web application server, the web server, through a HTTP GET request. Now, the web application sees the requested page is a secured page. So like before, right? It's going to send the response back. And again, this is going to be a HTTP 302 permanently relocated. And with the location header, right? With the location header, so that location header points to the OAuth server. I'm going to skip the root URL, so I'm going to do /OAuth, with some query strings. right? Parameters. And that's response type. Response type is code. So this meaning that we're asking the OAuth server to give us a authorization code. This is not the access code, right? This is the authorization code. So the web application is going to use this redirect URL, right? This location header, the URL in the location header, to tell the OAuth server what information it's trying to access, and that is by using the scope parameter. Right? It's going to say, hey, name, I want to access name, I want to access phone number, for example. I want to access email, so there's just a space in between, and it's going to be URL encoded. And then it's going to provide the client ID, right? Whatever the client ID is. So the web application, which is the client, needs to pre-register with the OAuth server. And during registration, it's going to provide the redirect URL, get a client ID, get a client secret. We're going to talk about that later. And then also going to provide a redirect URL. And this redirect URL has to be exactly the same redirect URL during registration. Otherwise, your server will fail to validate and will never return the authorization code. Right. I'm going to talk about what the redirect URL is. So for now, let's just keep that in mind. Right. So the redirect URL is whatever that is. Right. And the browser sees that it's a HTTP 302, then it's going to directly send a HTTP GET request to the OAuth server with this URL that is in the location header. And then the OAuth server will just quickly return the login page back. So it's just a login page, right? The login page, HTML. So the user then sees the login page, right? Let's for example, if the OAuth server is Google, right? Then the user sees the Google login page, right? Then he inputs the username, password, or the email address and password, right? So provide credential and submit the so then the browser submit the credential, to the OAuth server. What the OAuth server does is that at this moment is going to authenticate. Try to authenticate to verify whether the credential is correct. So after authentication, the OAuth server is going to turn the response, and that response is a access approval page, right? It's access approval page. So this is the page where you have seen it. You must have seen it if you used social media account login, right? It's going to ask you, hey, the user wants to, or the application wants to access your name, phone number, and email. Do you allow? Okay. And then the user sees the web page and says, okay, I allow, right? So, yes, allow. Then the OAuth server, verifies the client ID. It verifies the redirect URL, and it looks at the scope that the application asks for. And if everything is okay, then it returns a response to the browser. And this response is again a HTTP 302 with a location header, points to that redirect URL, which is the same as this redirect URL, okay? This one. And the only thing here that is different is that this redirect URL is going to be followed by a query string, which contains the authorization code. Yeah, this authorization code is generated by the OAuth server, After authentication and after access approval from the resource owner, which is the user. And then the browser sees the redirect URL, and along with the authorization code, it's going to redirect the user to that redirect URL. But what is the redirect URL? Where does it point to? Right, it points to the web application. It points to this client web application, right? And it's going to send the code, the authorization code to it. So that's the purpose. This redirect URL is an endpoint on the web application. Through that redirect URL, it receives the authorization code, right? That authorization code is a short-lived code. It's going to expire very, very soon. It's a short-lived token. And as soon as the web application receives the authorization code through the redirect URL, right, it's going to, so here, at this moment, it triggers this redirect URL, right? It's an endpoint, and it receives the authorization code. As soon as it receives the authorization code, it's going to do a HTTP post to the OAuth server. And it's going to provide the authorization code to the OAuth server. Not only that, it's going to provide within the authorization header, it's going to provide the client ID, the client secret, right? That's the basic authentication, right? So because the web application has already registered with the OAuth server, before you can use the OAuth server, the web application has to register with the OAuth server, right? The web API also has to register with the OAuth server. So the OAuth server knows what the redirect URL is. The OAuth server also gives the client, which is the web API, web application, the client ID, the client secret. So at this moment, it's going to post information to the OAuth server and provides the authorization code, right? It provides the client ID, the client secret. So this is in the authorization header, which is a basic authentication for the OAuth server to authenticate the web application, right? So this client ID along with the client secret is basically kind of the username and password for the web application for the client to access the OAuth server. So that's why there is this basic authentication between the web application and the OAuth server. And then it's also going to tell the authorization server that this current grant type is authorization code, right? So with this request, it provides the authorization code, it provides the client ID and the client secret. It tells the OAuth server that when you grant me access, the way to grant me access is by using the authorization code that I provided here in the request, the post request. Now the OAuth server authenticates the web application by looking at the client ID and client secret, right? And then validating the code, the authorization code, which is a very short-lived token. And then it will now return the access token. It will return the access token. Upon receiving the access token, the web application can log in the user. And that is very similar to here, right, at this place. So verify the user and then sign in the user, right? Here, then the verification has been done just because we received a access token, right? And then you can sign in the user right here, right? And then it will perform the same thing. It's going to create that cookie. It's going to send that cookie back in the response. It's going to be returning a HTTP 302 with location header points to the original URL, right? And then the browser will request the web application, request the original URL. The only difference now is that it actually, this time, it has a cookie, right? It provides the cookie. And the web application at this moment also stores the access token. It knows what the access token is. Now, in order to render the page, the original URL, right, the page that the original URL points to, the web application needs to access the web API, right? So now it accesses the web API, right? It sends a request. Let's imagine that's a HTTP GET request, right? So it provides the URL, and along with a barrier token, which is a token in the authorization header that says barrier, and this provide the access token that you received, the web application received from the OAuth server. Now the web API, what the web API does at this moment is takes that access code. It's going to verify with the OAuth server, and then the OAuth server says yes, the token is valid. Then the web API is going to return the result to the web application, typically in JSON format, right? It's data. So, and then the web application is going to process that data, right? And then return the page, the HTML, back. Right? So this is the whole process that involves the OAuth, right? So we are talking about the typical, the most complete, most secure flow, which is the authorization code flow. So this is the complete authorization code flow. So now there's just one thing that we also need to know here is that this access code, the access token, when it's returned, right, this place, when it's returned from the authorization server or auth server, it also usually comes with a refresh token. And this refresh token can be used when the access token has expired, right? The access token is what you use to access resources, which is in this case, the web API. But it has a shorter expiry date and time than the refresh token. However, you cannot use refresh token to access the web API. So then let's talk about what happens when the access token expires, right? Let's continue to use this diagram. Except that at this moment, we can't see which one is which, right? So let me draw this line here. And then I'm gonna say this is the user, this is the browser, and this is the web application, this is the OAuth server, and this is the web API here, right? So the user will, after this point, the user will use this web application many times, and sometimes it just returns the page right back. Sometimes it needs to go to the web API, and every time it goes to the web API, provides the access token. The access token needs to be verified with the OAuth server, and then verification. When the verification succeeds, the JSON data returns back to web application, and then the web application processes the result, sends the HTML back to the browser, and then the user, does something else, right? So imagine at this point, the access token expired. Then what happens, right? The user sends another request to the web application. The web application sees that this request needs data from the web API. Then it's going to provide, it does not know that the access token has expired, right? So it's going to send that access token to the web API through the authorization header as a barrier token, right? And then the web API will attempt to verify with the OAuth server, right? But the OAuth server says, no, this token has expired. And the OAuth server doing that by sending back a HTTP 4.4, and that's forbidden. So HTTP 4.3 forbidden. And the web API will also send that back. And then the web application sees this, then it's going to request another token with refresh token, right? So this step here is very similar to this step here, the post. There are two differences here, right? It doesn't have the authorization code anymore, right? This is the first difference. And secondly, the grant type is not going to be authorization code, right? So what it does here is it's going to do a post. It's going to post to the OAuth server, but at this moment, right, it's going to post to the token endpoint on the OAuth server, right? So I forgot to mention here, so this is going to be posted to the token endpoint. So I'm going to do a /token, that's the token endpoint. So we have several endpoints here, right? So this /auth is the authorization endpoint, right? Which is this endpoint. This is the authorization endpoint. And this endpoint here is the token endpoint. Here, we're going to post to the token endpoint again, but only this time we're going to provide, instead of the code, I'm going to provide the refresh token. I'm going to say refresh underscore token is whatever that refresh token is, right? It's being stored on the web application, right? It also provides the grant type. Last time the grant type is code. Now this grant type is refresh token. It's refresh token. Of course, it's going to provide the the client ID : secret. So, and this is going to be base 64 encoded. And this is for basic authentication. So now the OAuth verifies the refresh token. If the refresh token has expired, guess what's going to happen? It's going to re-trigger this flow here. It's going to send back the login page, and the user has to interact with that login page, submit a credential, and do that all over again with a new access, with a new authorization code, right? And if the refresh token hasn't expired, then it's just going to return back a new access token, right? And this is usually in a JSON format, with a new access token along with a new refresh token. And typically, the refresh token, this newly generated refresh token, has the same expiry date compared with the old refresh token, right? Just for security reason, it generates a new token back, and the old token cannot be used anymore. So with this newly generated access token, then the web application will try to access the same endpoints here, right? Just this one, and then it verifies that token with the OAuth server and tells that the verification succeeded, and now it returns the data back, right, in JSON. And then it process the data and return the HTML back, and the user will continue from there. Right, so this is also part of the authorization code flow, right? So, but this is about refresh token. Okay, so now we know how the authorization code flow works, but this is a web application, right? Which means that inside this web application here, you can really store the access token and refresh token securely because it's on the server, right? What if we're dealing with mobile applications where the application is deployed to your cell phone or anyone's cell phone, and that means that that application is publicly exposed, whereas compared with the web application that's on the server, and you have all of the ways to cure your web application. Right? When a mobile application is deployed on a cell phone, anything can happen on that cell phone, and you have no control whatsoever. Right? So in this case, we're going to also use authorization code flow, but it's going to look different. Right? So let's take a look at how that works. So again, we're going to have a user, right? And we're going to have the mobile app, and we're gonna have our OAuth server in this case, and we're also going to have the resource that the mobile application wants to access. Let's again use Web API, anyone's Web API, as long as it's registered with the OAuth server, or you can call it OAuth provider. Right? Again, in sequence diagram, so the user will access the application. Well, actually, before I talk about this, I want to show you, you will have to actually know something before we dive into this. And that's something that is called deep linking for mobile applications, right? That's very specific for mobile applications called deep linking. And this, you perhaps already have some experience with it. Right. So, for example, you received a email which contains a link, right? You receive an email that contains a link, and this link has a PD, it points to a PDF file, right? .pdf. And when you click on it, the mobile application is going to ask you, hey, you have several apps, for example, can open the PDF. Which one do you want to use? And you click, let's say you click the first one, and then the first application opens and the PDF is displayed here. Right? So when you use it, you probably didn't think about that. So now actually let's think about something else. On a desktop application, you use your browser, right? And you see there is an email address, and you click on here, and then your Outlook application is open, right? And then the email is displayed in there. How does that work? Right? So in both cases, you see the original link is just a link. How does clicking on a link open a application? Right? So that in mobile application is called deep linking. It means that you're linking a specific type of URL to a application, right? So it means that all three applications somehow registered in your cell phone's operating system and tells that operating system that this type of URL maps to this application, right? All three maps to this application. Then the operating system has no choice but ask the user which application you want to use, right? When you create your application, you can, in the manifest file, specify what kind of URL scheme you want to use. For example, your application is just called my app, right? And then you just want to map this type of URL scheme to your application. right? So as long as a link has this URL scheme, right, the operating system knows that this URL scheme maps to your application, right? So this is deep linking, linking a specific URL scheme to a specific application, right? And of course, this is better to be unique. My app :/ is not a good naming convention. Usually what people suggest is a reversed domain name, right? So for example, if you have a domain, it's called com.myapp.www, then you can use this as a URL scheme, right, and points to your application. However, this does not prevent other people from registering this, right? Just keep this in mind, and this actually has a security risk here. But anyway, what I'm trying to say here is there's this concept that's called deep linking, and when a browser receives this link URL, right, this type of scheme, it's going to attempt to open up the associated application. So with this in mind, let's go back to this sequence diagram and let's see how it works, right? How the authorization flow works in terms of mobile applications, right? The user open up the cell phone and try to access the mobile application. But the mobile application says, wait a minute, you really need to log in first, right? But the mobile application doesn't have a store of membership and all of the users. It relies on the OAuth provider, right? Authorization provider. The information is there. So then what it does is that it redirects the user to the, so let's actually add a browser here, right? It's easier to understand. Without the browser, we have to assume a lot of things. So I just realized that I missed the browser here. So we access the mobile application, and then the mobile application says you have not logged in, then opens up the browser with the URL, points to the authorization server, right? So this page from the auth server is opened, right? So then it returns the login page, and then the user sees the login page, right? At this moment, the browser is on top of the mobile application. You can't see the mobile application, but you can only see the browser, right? The user inputs the information, and then right click on the submit button. Then the username and password is sent to the OAuth server. And then here I'm just going to say it's authenticate the user, right? There's several steps. I'm going to skip those. Of course, when the mobile application open up the browser and trying to access the login page of the OAuth server, it also passes in the client ID as well as the redirect URL, right? And that client ID, as I said before, very similar to the web application case. That's when the mobile application is registered with the OAuth server generates the client ID, right? But in this case, the client secret is not stored in the mobile application. The redirect URL is the same thing as the web application. You need to provide it when you access the authorization endpoint, and then the OAuth server is going to validate to see whether the provided redirect URL is the same URL as the one that is in the record, right? Because when you register the mobile application with the OAuth server, you also need to provide that redirect URL. So the OAuth server has a record within itself associated with the client ID, so then the OAuth server can compare the redirect URL that is provided within the URL with the redirect URL in its record, right? So now, after authenticating the user and comparing the redirect URL, everything is okay, and then it's going to return with a authorization code, right? Same as before, it's returning the authorization code. And how does that return the authorization code? This again is a HTTP 302. I think you guessed right. It's a HTTP 302 with a location header points to, let's say it's my app, right? It's my app / whatever that, this mobile application has to register with the OAuth server. And when it registers, already provided my app / this is the scheme of the URL, right? So the OAuth server knows that this is the redirect URL, and then it's going to, at the end, says the code is whatever the code is. And then this browser is going to try to open this address, but it's a custom address that is associated with mobile application. And when the browser is trying to do that, the operating system, whatever the operating system, it could be Android, it could be iOS, right? It's going to open up this application, right? And feeds the information, the code, the authorization code, to the mobile application, right? And then the mobile application is going to now do a post, HTTP post, just like what we talked about before in the typical web server based authorization code flow, right? It's going to post all of that information. You can go back and take a look, but the key information here is it's going to provide the authorization code, right, to the auth server. It cannot provide the client ID and client secret. It can provide the client ID, but cannot provide the client secret, because remember, mobile applications are publicly exposed, right? So having a secret stored on the mobile application is insecure. So it's going to just provide the authorization code and client ID. And also remember that the authorization code is a short-lived token, right? So this post is going to send that short-lived token, the authorization code, as well as the client ID, to the OAuth server. And then the OAuth server is going to validate the code, and it validate the client ID, right? And if everything looks good, it's going to return this token, right, as HTTP response to the mobile application. So that's how it works in mobile applications. Well, but it's not that simple. It looks simple. It's simpler than the web application, but it's not that simple. But before we go into that problem, that security risk, let's use the web API, right? Let's just send the token to, because the mobile application needs to read data from API most of the cases, right? So it's going to, of course, it's going to request from a URL. It can be a post, it can be a GET, but it's going to have that token as a buried token, usually in the header, sent to the web API. And then the API is going to validate with the OAuth server, and if everything has succeeded, then it's going to return the information to the mobile application, right? Return the data, return the result. So here, I have skipped some steps here, right? Here I skipped some steps. It's usually after the login page is going to ask you to approve the access, because it's going to send the scope, right? So on the authorization endpoint, it's going to send the scope and say, hey, this mobile application needs to access blah, blah, blah. Do you agree? Right? So I skipped the steps. So this is a simplified diagram, but hopefully with all of the knowledge that I have presented before, you know exactly what I'm talking about. Now I want to talk about the security risk here. You see that because the deep linking, no matter how unique your URL scheme is, it does not prevent other applications. Let's use a double line to represent a different application to register, right? You cannot prevent a different application register the same URL scheme, right? When that happens, there's a possibility that here, let's go back to this diagram. There's a possibility that when this step happens, it sends a HTTP 302 permanently relocated response to the browser. There's a possibility the browser, instead of launching your mobile application, right, the mobile application that you as a developer worked on, it's possible it's going to launch a different dot application, right? This double line application here, right here. There's a possible, and that application immediately gains access to the authorization code, and now it can use that authorization code to request information from the web API. Of course, it needs to know the client ID, but like I said, mobile application is installed on the cell phone. It's publicly exposed, and other developers can actually create some code to actually gain access to your client ID. Possible, right? So with the code and client ID, the other application can access your web API. So how do we deal with this situation? And this is where we use PKCE, right? Proof Key Code Exchange, PKCE. And it's actually a pretty simple concept. That what it says is that the client, right, which is the mobile application, it needs to create a random value. It needs to create a random value right here. So the user wants to access mobile application. Mobile application sees that the user hasn't logged in. It creates a random value. Let's call that random value V value to represent that random value, and that's our PKCE. That's the key code, right? And this random value is going to be kept inside the memory of the mobile application, right? And then this value is also going to be sent to the browser, right? And then this URL is going to be sent to the OAuth server. And what here the OAuth server actually needs to store that value. And then everything else is the same, except that when it's trying to use the token, client ID, to get the access token, let me use a different color. Right over here. This is the place things can go wrong, right? But this place, instead of just use the code and client ID, it's going to also provide this value to the OAuth server. And then this validation here on the OAuth server not only validates the code, the client ID, but also validates this random value, which is the key code, right? How it can do that? Remember, it actually stored this value already, right? And when it stored this, it stores this with the client ID, right? Because in the URL there is this client ID, right? So it's gonna store that with this client ID and saying, hey, this client ID has a key code, a PKCE key code, right? And with that, it can validate this value that is provided. So imagine that in here, the other application gains the code, and also gains the authorization code, and then also knows what your client ID is, but it doesn't know about this value. But it's because this value, this random key code, is not provided inside this redirect URL, right? So it doesn't know. So that's how PKCE is being used to add another layer of security to your mobile application. And usually for mobile applications, we don't use refresh token, right? Because refresh token has a longer expiry date and time, right? It lives for too long for mobile applications because it's public exposed. Even with PKCE, we don't want the code to be to live too long. When the access code expires, we want the user to authenticate interactively, instead of just use refresh token to get another. All right, since we have talked about the mobile applications, how mobile applications work with the OAuth authorization code flow, then why don't we also cover desktop applications as well? Well, one of the main problems with desktop applications is this redirect here. Okay, the deep linking concept isn't readily available for desktop applications. Right? You can't register a custom URL scheme to your Windows operating system, right? Or your Linux operating system, or whatever the operating system is working with. So how the redirect works here? Right? I'm not gonna redraw. I'm not gonna draw this sequence diagram again. I'm just going to use this existing diagram. So imagine this, instead of the mobile application, it's a desktop application. So how does the OAuth server sends the authorization code here? It has to use a HTTP 302, right, redirect. But then how does that work? Why it has to use the HTTP 302? Because even with desktop applications, we're going to work with a browser, right? So the user try to use this application, the desktop application says, wait a minute, you have not logged in, so it's going to open up a browser and it's going to show the OAuth server login page, right? And the user will log in, and the OAuth server is going to authenticate and ask the user whether you give permission to the desktop application, and you say yes. And now it comes to this particular step. It's going to send, right, this particular step here is going to send the authorization code back to the desktop application, right? But with this, the browser can't open up the desktop application. The desktop application won't be able to receive the authorization code. So there's different ways to deal with the situation, right? One of the ways is that when at this moment, when the desktop application tries to open up the browser, it also spins up a temporary web server. And this web server maybe is listening to a specific port, and right, and then it's going to respond to a particular IP address. For example, if you just say 127.0.0.1 colon 8889, for example, right? So this is a redirect URL. This redirect URL, when you register this application to the OAuth server, you have to register that as the redirect URL, right? And you also have to provide that to the authorization endpoint. And this, instead of my app : is going to do http : / 127.0.0.1 : 8889. So then, because this web server is listening, and then it receives the information from the specific port, and then it's going to take the code, and then it's going to continue just like the rest, right? Continue the rest of the steps. The rest of the steps are the same as mobile applications, right? That's approach number one. Another approach is that you can have this desktop application work with a remote server. And what the server does is that it has a specific domain name, right? For example, this server also is called myapp.com, and when you register this application, instead of this, you do http / well, it has to be https at this point. This one doesn't have to be https because it never goes to public network. It's just within the computer. right? This HTTPS, it actually goes out to internet. This way, the server, right? This application has to send information to the server. That's why this has to be HTTPS, and then it's going to be this. Okay, this is HTTPS, and then we're going to have myapp.com, right? And then as this step, the only thing that is different is instead of this or 127.0.0.1, it's going to use this URL, right? And this URL, what it does is going to send the information to the server. And another thing that is different is that once this login page over here, once the desktop application open up the browser, it also does something. Instead of doing the spin up a web server here, it polls, right? Polling. Very frequently it's going to poll. For example, every a few seconds, every 5 seconds, it's going to poll the server to see, hey, did you receive it? Did you receive it? Did you receive it? Until it receives the authorization token, then the rest of the steps are exactly the same as the mobile application.